All right, so here we go. This is number 6 from our mid-chapter review sheet here. This one's actually really similar to number 5. Easier in a lot of ways. So here we go. So we've got the same incline. So here's our incline. Inclined at 30 degrees, and we've got this wheel that's rolling along. When it gets to the bottom of the hill, the wheel is rolling at 6 meters a second. We know the mass, but you can definitely solve it without it, which is what I would encourage you to do. The problem tells you that it's disk-shaped, so your I is 1/2 mr squared. All right. Question A wants to know how far it goes up the hill before it stops and comes back down. So we're looking for the point, well, we're looking for this displacement that it goes through before reaching a height at which the velocity is 0. Okay? So, if we call this point the start, and we call this point A, as in question A, then what we know is the total energy at that start point has got to equal the total energy at point A, right? So, at point A, I'm sorry, at the start, I've got two types of energy. The wheel is moving, so it's got kinetic energy, and it's rolling, so it's got rotational kinetic energy. And at this point where it stops, the only type of energy it's going to have is GPE, right? So the kinetic energy that it begins with is just 1/2 m times, oh, we know the velocity, it's 6. So I'm going to do 6 squared, plus, well, the whole wheel is rolling, right? So your RKE, remember, that's just equal to B times your kinetic energy. And that's got to equal your GPE, which is m times 9.8 times some height. Okay? So there's our setup. The m's cancel out here. And so you end up getting 18 plus 9 equals 9.8h. And solve it, and your h turns out to be, I didn't write it down foolishly, 27 divided by 9.8. It gives you 2.76, I guess, 2.75 meters. And then you can do a little bit of trig and find your hypotenuse, right? Because if this is 2.76 and this is 30 degrees, then your delta x is going to be basically just double that, right? So 5.5, I have 5.51 on my answer key. Yeah, right, 5.51. Okay, so there you go. So that's how you do part A. All right, part B wants to know, it says, all right, well, there is a point where it's gone half of this distance, right? And it wants to know what the velocity is at that point. Okay? So, I guess there's a couple of ways of doing that. I guess we already know our total energy, right? It's 27, right? So I guess we might as well just go from there. So the idea, let's call this point B, okay? At that point, well, you're halfway up, so you're going to have half the height. So the height at that point is going to be half of 2.76, which is, what, 1.38, I think, meters, right? And we're looking for the velocity at that point. Okay? So what we know is our total energy at the start has got to equal our total energy at our new point B. And the total energy at the start, we'd already figured out, it was 27, I guess technically it was 27 m, right? Because we'd canceled out the m's, okay? And that's got to equal the total energy at B, which is the GPE, which is m times 9.8 times our height of 1.38, plus the KE, which is 1/2 mv squared, plus the RKE, which is B, which is again 1/2 times the KE. Okay? So once again, the m's all cancel out. This ends up giving you 13.5. So you get 27 equals 13.5 plus 0.5 v squared plus 0.25 v squared, and solve it. So you get 13.5 equals 0.75 v squared. So let's see, 13.5 divided by 0.75, square root it, and it gives you 4.24 meters a second. which interestingly is the same answer as 5b. So anyway, there you go. That's how you do those.